Hi ladies and gentlemen, it's Mr. Green again, another in my series of videos for geometry. We're very quickly approaching the end of the semester, so I just want to make certain we're getting everything covered like we need to. Unit 4 has come and gone. We're working in Unit 5. As a matter of fact, we're more than halfway through Unit 5, so we're getting close to the end of it. Don't forget, make corrections. It will help your grade. If you see any failing grades, go and make a correction to it. Due dates. Due dates are very set in stone. We cannot deal with that a whole lot. You need to get things turned in when they're due, okay? So, moving forward, we looked at the perimeter a couple of days ago. That perimeter was the distance around a rectangle or distance around a polygon. What we're looking at now is circumference. Circumference is slightly different. It's the distance around a circle. Well, how's that different? Well, a circle is not a polygon. That's one thing you need to keep in mind. So there has to be a slightly different formula for that. And, there are some parts of the circle that I want to make certain you understand. If I go from the center to the edge of a circle, it's a radius. And a circle is defined as all points that are equal distance from that one point. That's what the radius tells you. It's how far away they are from that one point. Now, if you want to go completely across the circle, you're looking at the diameter. That's the distance all the way across the circle. Now, back in ancient Greek times, they discovered that circles were not polygons, so they needed to have a different formula for calculating the distance around a circle. And they could see that if they took the circumference of the circle and divided it by the diameter, they kept getting this number, pi. Okay? Well, pi is a number that they worked on and worked on and worked on and worked on and worked on, and you can't find the value of pi. It is only estimatable. It is so many digits out there, and they can't find the end of it. It just goes on and on and on and on and on and on, kind of like a teacher. Blah, 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 blah. It goes on and on and on and on and on and on. Okay? So what we do with this is we say, diameters is difficult to deal with. We'd rather deal with radius. We put two radiuses in for the diameter, and we come up with our formula for circumference. It's equal to 2 times pi times that radius. Now, when we're writing our answers, a lot of times we need to leave pi in our answers. Okay? Just like it was a variable. Just treat it like it's another variable, just like it's x or y or w or anything else. Pi. Leave it in the answer. Okay? Don't try to multiply it by an estimation of it. Why? Because pi is a lot more accurate than saying 3.14 times. If we want to have a certain accuracy, we'll tell you what value of pi we want you to use. Otherwise, leave pi in the answer. Okay? From the same perspective, area of a circle, very similar type situation. They discovered that the area of a circle is pi r squared. Well, we know pi r not squared. We know pi r round. But the formula for a circle, pi r squared, that's the area of a circle. Okay? Let's look at a couple of problems here. If we said that the diameter is equal to 2, then our circumference is going to be 2 times pi, because I multiplied 2 times pi, because that was the diameter. My area, I need to find the radius for it. So I'm going to take 2 is equal to 2 divided by 2. That means it's going to be 1. And I can stick that in for r squared. 1 squared is 1, so my area is going to be pi. Okay? Pick another value. What if we said our radius was 6? Then my circumference is going to be 2 times 6 is 12. 12 pi. Come on, Mr. Dyslexic. 12 pi. Okay? If I take that same 6 and stick it over here into my formula for area, 6 squared is 36 pi. Can you see how I'm leaving that term pi in the answers every time? This is considered more accurate than multiplying it out with 3.14 or any other estimate for pi. So we just leave that pi in there. Okay? Now, one of the things I want to point out to you is when we take a circle and we take some portion of that circle, like 60 degrees here, that is actually 60 degrees out of the entire 360 degrees. So we can actually find the area of the circle, and if we found the area of this circle to be 36 pi, why would that? Well, let's say our radius was 6. Then I could take this 36 pi and multiply it times 60 over 360. And what do I get? Well, let's see, the zeros will cancel out. 6 goes into 36 6 times. 6 goes into the 36 6 times. I'll wind up with 6 pi. So this little shaded area in here is simply 6 pi square units. Could I do the same thing at 90 degrees? Sure. Let's say my radius is equal to 6 again. So my area of my circle is going to be 36 pi. And I'm going to take that 36 pi times 90 over 360. My zeros will cancel out. That'll go into that 4 times. 4 goes into 36. 9 times. So what am I going to be left with? 9 pi. 9 pi. Do you see how I'm using that? I'm leaving pi in my answers in every case. And I'm just using the ratio of 60 divided by the entire 360 degrees. Or 90 divided by the entire 360 degrees. Well, you know what? What they're trying to show you with this next slide is that if I took a polygon and stuck it inside of a circle, what do we got? We got little gaps here that are not quite being filled up, right? See that little yellow area there? Not quite being filled up by the polygon. So if I took the area of the polygon, how would we do that? Well, it would have to be one of those apophthegms times the perimeter type equations. But we would find something that would be very close. And the more sides on the polygon we have, the closer that these things, this yellow, the smaller this yellow area becomes in total. So that's one of the ways that they proved the area of a circle was equal to pi r squared. Was that as they got more and more sides on their polygons and calculated the area, shrunk down this yellow more and more, it got closer to pi r squared as the answer. And you can just sit there and do that over and over and over again. But that's one of the historical facts that goes along with geometry. Okay? I do appreciate the fact that you guys have been real good about telling me that you're in geometry and what section you're in, because it does help me find your records and it does help me answer your questions a whole lot quicker. So I'll look forward to seeing you next time.